Next we have is Srikanth Mohan. Srikanth is a quality architect with EPAM. Srikanth is a seasoned cloud solution architect with a strong focus on Azure technologies and a proven track record of 20 years in cloud product visualization, validation. And he is going to talk about unlocking resiliency methods and approaches for validating Istio services mesh in a microservice environment. Over to you, Srikanth.
Okay. Today's topic for me is about resiliency testing. And in the resiliency testing, how do we do in service mesh? So people, how many of you here have used any of resiliency testing tools? Might be very few. So here, right, the topic today, I will be splitting it into three parts. The first part will be mostly on chaos engineering, what is chaos, why we need it, why we need resiliency testing. The second piece to it, a bit of an introduction about service mesh and Istio. So the crowd, we may not have all of them have understanding about Kubernetes, Istio, service mesh. So we will give a small introduction about that and some of the silent parts of it. And then we move on with the detailed test scenarios and a demo with Istio service mesh. So this is how the flow of the presentation will be, right? So coming out to chaos engineering, you will be hearing this word quite a lot. Might be in one of your presentations or in your organization's key items which you need to accomplish, right? Failure is inevitable. Say, for example, we have Chandrayaan-2 failed, but what they came back is with a resilient movement of Chandrayaan-3, right? All the learnings of the failures, we have to adapt and we have to move up. And this failure is just not only for the software applications, it's for everything, right? With respect to software applications, what we miss or what we lose a lot is mostly on the branding and on the cost. Say, what if Facebook goes down? What if WhatsApp goes down? We will feel like something, something is going to happen in this world, so these two services are not there, right? So that's makes a big impact when we are selling the products. So what is chaos engineering in a way? So chaos engineering is a mechanism through which we ensure the products are reliable and serviceable all through. It is not an work which is randomly doing, right? People talk about monkey testing stuff. It's not a random process. It is a well-defined process through which we achieve resiliency. And it is not one particular team does it. See, even though I'm presenting it in front of a testing audience, it's just not testing audience. It will be for the developers who build the application with the resilient mode. As a testers, we test it for the resiliency. And as a operations team, like a DR team, who works it out, what happens in the production. It's also those learnings comes in as a chaos engineering practices. Now, with these two done, what might be my different dimensions where the faults can happen, right? The faults can happen either in a infrastructure level, it can happen in a service level, it can happen in the network level, it can also happen in some other dependencies level. Here I have added even in the devices UI level, okay? We also have something else, UI chaos testing, okay? Where our monkey scripts will run through the UI and disrupt the UI. So the concept is just not to be on only Kubernetes or cloud or things. It can be applied everywhere. Leave upon, this concept is just not for, people have been hearing about reliability testing, chaos testing in the recent past. Might be from 10 years, from Netflix. But believe me, even before that, even for monolithic applications, people were doing resiliency testing. And like in the form of stress testing, they used to have disk.io scripts which will be running in the server, which will create an CPU and the memory hogs, okay? And then run your stress test scripts. So that's how they have been testing about resiliency testing in the past. And even now, most of those inherited ideas, right, will still continue, okay? So these are some of the, as I told, these are some of the dimensions of chaos. even when you speak about security chaos, why it is important? Because so if a certificate expires, or if there is a hack happens, okay, if there is a breach in your system, how fast is my organization is able to recognize it and recover from it? So those are all parts of the resiliency testing scope. Now, because I'm speaking about service mesh, Istio, so these two names comes mostly towards the networking side. So I want to give a bit more elaboration on that, and we will also talk about it while going to the particular slides on Istio. But if you're looking at in the networking side, right, what are the different types of disruption which we can create or we will encounter in a networking side? It can be a latency, a delays, right? Or it can be an abortion of services. It can be a configuration change. So people would have been with production supports, right? Or you've been a part of the team who does the RCA for whenever production issue happens. They might be hearing this word, drift of configuration files. So these are some, it might look small, but the impact in the production is very high, okay? So those are other things. And some of the areas on the services getting restarted or the entire node getting restarted. So you might think why he is bringing up in a cloud world, right? Even in the cloud, these things happen. End of the day, either it is AWS, either it is Azure or Google Cloud, end of the day, it is all running in one server, and the server is susceptible to restart, fail, or power off also. Okay, that is the reason all the vendors gives about the redundancy, multi-tenant distributions, they bring it in and get more money out of all the vendors due to that, okay? So that's a summary about the networking and some of the aspects where the chaos can be applied in network. Now we are moving down to the core topic of this presentation, service mesh and Istio. While going to do that, I'll pick up an application which will be like a storyline, right? We need to hear as a story because this is a pure technical talk. So we'll pick an application. We will move the story along with what our learning with this application. This application is a simple book info app application, which is part of the Istio's site, which we have picked up. So this application has 3 services, basically one on the details review, and the ratings part. Right? So, and this application, when it is in a monolithic world, how it is been. So I'm trying to give you why an Istio has to come in place, and then we will move on to, because the topic is on microservices, how it affects up the microservices. When you are looking at a monolithic way, you could see that most of the services are being coupled into one single container, and all the areas on authorization, authentication, networking, logging, everything is being coupled. They centralize it and they manage it. So that's easy to manage, right? But when we move on to microservices, we speak about independence of the services, right? What is the basic of microservices? They say it's all decoupled. I will be able to run my service without a dependency on other service. That's a basic facet of microservices. So how I'm doing it, right? So that service will be split like this. Right? Each of them has to be managed for authentication, authorization, logging, monitoring, observability, whatnot. We have to make it, right? So this is a good thing that I will be able to run my services individually without any fault. But it also creates a problem for us. So many of us, when we are building our tech decks for microservices, we will pull up this point. We have multi-point failures. Our points of managing it is difficult, right? And how I am going to see what is happening inside the system, right? In a microservice, it's going to be difficult. And distributed tracing is again a bigger part in a microservices world. So these are some of the challenges which we face when we are moving our application into microservices. So now you have a challenge. How am I going to come out of it? Okay. Before I move there, I want you to get introduced to a small concept called sidecars. It's something like our sidekick of Batman and Robin, right? a sidecar, a guy who will do my work for me, right? Like might be, we give a lot of, offload some of our work to our juniors to do some of them. Like, so something like that, we have a sidecar. What is a sidecar? Sidecar is again a container which sits along with the service. I will show you during the demo how it will be looked at. But what is it specially for? It does some of the actions like file handling, it does logging, monitoring. Some of those inputs get driven by the sidecar. And that one of the type of the sidecar, we are calling it as proxy. The next slide, we will see why the proxy. But still, the proxy is detailing, right, what the proxy does. The proxy will be as the name follows, it is a layer through which I can get the things done, like you manage my TLS, manage my user entry into my container. All of it will be handled by the proxy, but it is not embedded into the business logic. So if you have seen the previous slide, no? So we are having all these details like networking, authorization, everything as part of the service. Now, with the proxy coming in, we are removing those aspects into a different area and manage it. So that is the reason a proxy, which will be treated as a sidecar in this in Istio. So now is Istio. Now we heard about what is a sidecar. Now we also heard about what is a proxy and what it does. So service mesh does the thing of traffic management. It helps you to divert the traffic if it is an A/B testing. Say you have multiple services. I need to divert the traffic for one particular service more and another less. It helps you to do that. It also helps you with the configuration downloads. Say if you want to apply a security policy across the cluster, you can be able to do with the service mesh using these tools, right? So along with that, it also does observability and service discovery. Service discovery is something, and how am I going to visualize it, right? So those are all tools. The service mesh helps you to do it. How it does, right? So I don't know what is the clarity in here. I'm not able to see it much clearer, but I suppose the PPT is big enough, right? So it has two levels. One is called the control plane, one is called the data plane. Data plane is on the services, and the envoy proxy is the proxy which we spoke. It sits on each of the services, and this will act as a proxy to whatever the control which I'm doing. When I say that, say if I want to divert the traffic, I will make the changes in the control plane, and it will be deployed onto the data plane using the agents, Istio agents, which will be part of it. Okay, so this Istio agent is part of the envoy proxy. So it's not a separate entity, it's part of the envoy proxy. So this is how, and all the logging, monitoring, traffic control, security and certificate management, every aspect of it is being managed by that. Okay, so now we all gone into Istio service mesh, sidecar, proxy, too many things, right? So coming on to, let me give you more technical depth here. With this, keep that in mind. These are all some keywords which you are seeing here. Once you go back to your desk, go start looking at it. It will make more sense. Okay, this 30-minute presentation will give you only a high-level insight about it. But once you start looking into it, reading about it, these slides will make more relevance to you. Now, we spoke about Istio and all those things. What is the resiliency part? How Istio provides some facility for me to do testing there. Okay? So that comes with the Istio's inbuilt capability. Istio provides two basic capability for testing. One, how I can introduce a delay to it, right? We can even add this and send it as a configuration. And we can also have an abortion of about injection. So what is like, you have a 500 error or a 403 error. We can create those errors and we can send. Okay, we can inject that, and certain services will respond to it like that, because we are able to control it. Why we are able to do? We are able to control it through the APIs of Istio. Okay? You will see that in the demo anyway. Now, You heard about two of the fault injection capabilities of Istio. Now, this is the main deck of this total presentation, which you need to understand a bit or ask questions during the Q&A, okay? So with that in, what are the different types of scenarios I'm going to do and how I am going to do, right? So coming to the left, right, traffic shifting. So traffic shifting, I spoke about traffic management. Istio has a feature. When your team is implementing it, they will have a traffic shifting feature. How am I going to test it, right? So I apply the traffic rules for the tool and see you can do with this, you can do an A/B testing, okay? A/B testing is like a service A, service B will divert the traffic for better service and do validation. So this is part of your deployments also. So that can be done, and also we can see what is the response rate to it. We can compare two different versions of a particular service. The next is on injection of fault. Injection of fault delays, right? It's very important because when we are building an application, we also need to ensure that any failure, any delay in my service have a feature called retries. A developer has to build it, or in a deployment file, they have to create it. So whether that is being done and that is adequate or not, that will be tested using the delays injection. And token expiry. This is more to touch upon the security aspects. If my token gets expired, okay, in the production, this is a very common scenario in production, where the token gets expired, what happens? You've heard about my initial slides, configuration drift or configuration change, all those things will come under this. What happens, how I have to respond, that can be done. The next is on the about request. So again, here about request is again, when developers are building their services, right, there are few areas where they won't even bother, like they may not have taken an insight on how I have to handle certain errors if it is emanating out. Okay, so those things can be validated with this scenario. The next, circuit breaker. Circuit breaker is a design pattern in the microservices world. Okay, what it really does, there are other patterns, bulkhead and other patterns on the microservices world, and there are resiliency patterns which so one of the reference you can look at is Microsoft. They have an extensive documentation on each of these patterns. Service coming back only on circuit breaker. So if there is a failure which is happening in one service, that failure should not cascade back down to your other services. That is what a circuit breaker will enable, okay? So all these policies for these will be applied in a service mesh. So how I am going to validate? The last is on the connection pool. Again, if you are setting a certain amount of connection, say due to various reasons, say for a DB access, they will have a certain amount of connections within set. If I have a certain amount of connection for a certain connection pool, how my system is going to behave in a higher load, right? So that, again, can be tested with this. So these are, whatever I explained to you now, it's all the high-level concepts, right? So, and how I am applying, I will use, if you're seeing in the slide, there is something called chaos action. What action I will be doing to test it, right? So how are you going to do that action? Is using some of the tools available in the market. So a couple of tools which are there. One is Litmus, which is a CNCF authorized tool. Chaos Mesh, again a CNCF tool. These are all open source. Chaos Toolkits is another. Gremlin, Azure Cloud Studio, fault injection, FIS from AWS. All these tools can be utilized for doing it. Now, coming down to the demo, what we are going to do, we are going to simulate the load for the application using JMeter, okay? And we will be creating one abort failure for detailed services and two delay fault for review and abort services. When you are looking at it, review has a couple of versions. We are version 1, 2, and 3. And based on that, we will be doing it. Now, I don't know, you are able to see it clearly? No. Okay. So we call, this is when they might be sharing the PPT with you. So this is mostly, it's an experiment file which will be shared, right? So I'm going to use Kiosk Toolkit for the demo, okay? And what this demo will say. So it gives an introduction about how my experiment is about, and we will explain that in the particular thing, okay? So this particular demo is, again, we will coming back to the same application, okay? This application is the one which I showed in the earlier stages. So this application has 3 stages. One, the details, the one on the reviews, and on the ratings. So if you're looking at review has multiple versions, V1, V2, and V3, okay? Now, when this application is getting deployed, how do you deploy this application? Right? Any of the applications in the real world, right? They will be deploying using a deployment file. Now, in a real production environment, it will be Helm chart or Terraform scripts they use. So when you're doing it, you are seeing something called services being highlighted here. Services are the communication layer through which each of the pods will communicate. And the deployment file is a file on which it will detail about where my containers are, how my containers are managed. All of it will be detailed in the deployment file, in the deployment object. So these are all objects, services, deployment, these are objects of Kubernetes. Okay, so once we deploy it, right, how we see it? So if we are looking at here, we are seeing 2 by 2, okay, kubectl. What is 2 by 2? One is the main container. The second container is the sidecar, which we are using. You remember the sidecar which I spoke in the earlier of the slide? The sidecar which we are here. So this is important. Here you will be seeing this. And we have to enable this sidecar before the deployment, okay? So most of our ops teams will do this work. But as a tester, you need to know how this deployment file is, how you have to read it also. So it will be good to, if people who wants to get into chaos engineering frame, you please read Kubernetes basics and then move on to it. That will really help you. So the next piece is on the virtual services. We saw now here, right? We are speaking about the virtual services, and the virtual services, different types of services, which I am mentioning it here. V1, V2, and V3, and the distribution. Here is what I spoke about, the distribution of load between the services for A/B testing, right? So here you are looking at subset. Subset is nothing but which version of the service which I need to go. That will be defined in the subset, and that will be defined in something called a destination rule. So if you're looking at the version, right, version V1, and in the deployment side, you will also see that version. So this mapping has to be proper, okay? And this is very important when you are doing the test or creating the test. Now coming back on the main experiment. So the experiment is Kiosk Toolkit I'm using. So the experiment has 3 stages. One is a steady-state hypothesis. The steady-state hypothesis will tell you what is my current state of my application and what will be my, after the application and running, what will be my end state. It's like a precondition and postcondition of my application. Okay? So here I'm just going to do the test on whether it is 200 is coming up or not. Okay? Then when you go down, it will be coming up. Yeah. So we are also having the different failures I'm describing, one on abort failure. If you're looking at there, you are seeing Python, function name, and stuff. So beauty of Kiosk Toolkit is you can even write your own functions. Say, for example, your application doesn't fall under any of these categories, which the plugins are available. You can write your own plugins and integrate it. It will be very easy. Okay? So that's the reason we can write it in Python. We can do that. So here we have added the faults, and also, end of it, we also have something called a rollback. Now, we have done the testing. Once I complete the testing, what I will do? I need to see the rollback of my application. So now, here, I just pause a minute. Right? So now we are going to, here it is, Kylie. So now we are running the test, right? So while running the test, how do I visualize what is happening in the test? Okay? So you need to use something, some of the observability tools available. Here I'm using Kylie, which is part of Istio, and I'm using it. But in a real deployments, you might use something else. Okay? You might use application insights, or Neuralink has a lot of tools, Dynatrace has a lot of facilities. You might need to use those. Okay? And they will give you very detailed amount of information about what exactly things are. Now, what is happening in my test is, it is all setting up the failures. Now, if you're seeing here, the actions are getting deployed. And if you're looking, so now it's been deployed, the fault is deployed. The first slide, the fault is deployed in the review services. Now, for the rating services, again, the abort fault is being applied. So now we are looking at it, whatever we are doing in the test is getting applied as a configuration, right? So since Istio is a management layer, we can utilize those APIs of this management layer for our advantage for testing. So now you are looking at it, this is how the application look will be. So many of you guys, when you are looking end-to-end testing and all, right, you might have the flows like this. You will see where the order flows one place to another. It does something like that. Now my system is in a proper state, and it's been applied, and there's no loader coming in. Now I'm creating a load for it. So we need to simulate it with the production load. How do I simulate with the production load? I am taking advantage of JMeter. So for my example, I'm using JMeter. You might use any of the tools which you prefer. Okay? But the load creation is a very important part to simulate the production load. Once the load is created, right, now it is also rolling back. Right? Now, this particular Kylie comes up with 1 minute refresh. So it was not refreshing before that. Right? Now it will refresh. Now you are seeing here, different faults being applied here in various stages. And various versions are coming in. V1, V2, V3, the faults on review, faults on details. So this is how you will manage. If there are, if these faults, whatever we are testing, here I did manage the faults in my application. But if the application, our developers have made adequate thing, it should be coming up properly back to you in your SLA. So this is how the total testing part of with Istio can be applied. Okay. So now, since it has been a rollback has happened, now all my configurations are back to its normal. Right? I'm done. So that's with Kylie and my coming close to end of my presentation. Only one slide is there. Okay. So we spoke about this, and then in any of the monitoring things, you will have these monitors available. The side, it can be a Grafana, Prometheus, or application monitor, whichever tools you have. And we also can get into the insight of logs using Jagger for distributed tracing, which will be really helpful for you guys. I think that's coming to the end of the presentation here. And some of the references, and you can always connect me with the mail ID mentioned here. Any questions, if I have time here? No time? Okay. Thank you, everyone. Thanks for the time.